This was the solar system 4.6 billion years ago, when the Sun, Earth, and all the planets had not yet formed. Drifting in the universe was a gigantic gas cloud made up of countless atoms of hydrogen and nitrogen. If not for a few supernova explosions that occurred somewhere in the universe, this gas cloud might have continued drifting in space without any change. However, the shock waves from the supernovae compressed the gas cloud, causing the temperature at its core to rise suddenly. Finally, nuclear fusion was triggered. Thus, about 4.5 billion years ago, the Sun finally began to shine and was officially born. But compared to the warm Sun we admire today, the young Sun was far less stable and gave off much less energy. At the same time, Earth also began to form from cosmic dust and free gas, gradually condensing into a disc-shaped body. This disk pulled in dust, debris, and even nearby asteroids, making it heavier and heavier over time. Within it, a solid metallic core had formed, heating up under immense gravity, with temperatures reaching as high as 6,000 degrees. And gradually, a liquid outer core formed around it. It was this convection between the solid metallic inner core and the liquid outer core that created a natural generator for Earth. And thus, Earth's magnetic field was born.
Earth's magnetic field acts as a shield, deflecting deadly cosmic radiation.
But then again, at that time, Earth had no life at all worth protecting. The entire Earth was nothing more than a boiling sphere of magma, glowing red and steaming violently into the sky. In this very stage, young Earth faced its first great catastrophe.
Earth drew near a primordial planet, later named Theia.
After the violent collision, massive debris gathered to form the mysterious satellite we now call the Moon.
After this collision, Earth spun much faster. A day lasted only 5 hours.
But after hundreds of millions of years, the Moon's gravity slowed Earth's rotation. And thus, it became as it is today.
Yet at that time, Earth was far from a habitable planet.
Earth was entirely covered in lava, while relentless meteor storms raged above. There was no room for any form of life to exist. At that time, Earth was just like Venus today, misty, covered in lava and battered by acid rain. But the miracle was that around 3.7 billion years ago, the first living organisms appeared on Earth. They were primitive microorganisms, living in a world without oxygen. For at that time, Earth had absolutely no oxygen. For 2 million years, these microorganisms lived in hidden shores, gradually forming limestone structures called stromatolites. These are the remnants of Earth's earliest geological era, Warshoni, the Archean. Even now, these most primitive life forms still survive.
They didn't even have a cell nucleus, Clay. So simple.
It is precisely because of their extreme simplicity that they have survived to this day. They could even survive in hot springs over 100 degrees, or in icy, highly acidic waters.
After some time, certain bacteria learned to photosynthesize.
At first, the oxygen produced was absorbed by iron in the rocks, oxidizing them. But around 2.45 billion years ago, oxygen production exceeded consumption and began escaping into the atmosphere.
This triggered what is known as the Great Oxidation Event.
For organisms that did not need oxygen, it became a deadly poison. This biological catastrophe wiped out a vast amount of life. Their remains became the first hydrocarbons as the Proterozoic began, around 2.46 billion years ago. Oxygen levels reached 2%, only 1/10 of what we breathe today.
So, traveling back to that era without a mask, we would suffocate instantly from the lack of oxygen.
Before then, Earth's atmosphere was mostly methane and carbon dioxide.
These gases created a greenhouse effect, much like the one we fear today.
But at that time, this greenhouse effect actually saved Earth more than, keeping it warm enough to prevent the oceans from freezing. But once oxygen consumed the methane, the greenhouse effect weakened, and Earth's temperature dropped sharply. Although oxygen levels rose, that didn't mean Earth became a pleasant place. On the contrary, we might have frozen to death. For Earth was about to enter the longest ice age in its history, the Huronian glaciation. This ice age lasted for 300 million years. Earth, once as hot as Venus, had turned into a planet completely covered in ice.
In some regions, temperatures dropped to between -20 and -70 degrees Fahrenheit.
In such an environment, no new life could possibly emerge.
But miraculously, some bacteria still survived.
For example, cyanobacteria and archaea.
These were microorganisms that had existed long before. Hearing this, you might think life could only stop at such a primitive stage, right? So the question is, how did dinosaurs and humans eventually appear?
What could change everything was our sun.
Throughout the 300 million years of the Ice Age, the sun gradually grew hotter. Eventually, much of Earth's thick ice began to melt away. And this opened the way for the rise of multicellular organisms and complex plants.
From that moment, everything began to move forward.
Over the next billions of years, life on Earth grew ever more diverse, with countless flourishing species. The most important milestone was when life finally made its way from the oceans onto land. Meanwhile, as Earth warmed again, it entered the Carboniferous period.
It was an age one could truly call a zoo on steroids.
Around 300 million years ago, long before dinosaurs appeared, Earth was swarming with giant insects. The continents themselves were constantly changing. Around 750 million years ago, the supercontinent Rodinia began to fracture and gradually split apart. The continents split apart, floating across the oceans. Then they merged again, forming another supercontinent called Pannotia.
But soon after, Pannotia too met its fate, breaking apart.
The colliding landmasses gradually formed the great mountain ranges we see today. Finally, about 335 million years ago, these drifting lands merged once again.
This gave rise to Pangaea, a massive supercontinent.
And this enormous supercontinent gradually broke apart once more. They became the continents we know today: Africa, Europe, Asia, the Americas, and Oceania. Why did the dinosaurs go extinct? The most common explanation is that a giant asteroid struck Earth, triggering this catastrophe. Scientists have even identified the impact crater today, in the Gulf of Mexico. But fewer people know about the Permian extinction, which occurred at the boundary between the Paleozoic and Mesozoic eras.
In fact, this extinction was the most catastrophic of the 5 known mass extinctions.
In the most catastrophic age in Earth's history.
We often say that if dinosaurs hadn't gone extinct, humans might never have been born. But without the Great Permian extinction, dinosaurs might never have appeared. Yet at that time, Earth showed no signs of the disaster to come.
During the Permian period, 2 main groups of creatures flourished for nearly 40 million years.
The ancestors of modern reptiles were called Diadectomorpha, while the ancestors of mammals were Synapsida. Speaking of synapsids, they might even have paved the way toward intelligent beings.
But this evolutionary path ultimately came to an end.
In other words, our existence is not only because the dinosaurs went extinct. It was also thanks to the great extinction in the distant Permian era, long before dinosaurs appeared. One could even say it was the complete opposite. Overall, the climate at that time was quite dry, though it varied by region and was somewhat similar to today's. But the atmosphere back then would have been unbearable for us today. Although oxygen levels were twice as high as today, carbon dioxide levels were about 3 times greater. In such an atmosphere, we wouldn't just get headaches, we'd likely be poisoned and lose consciousness. Especially at the end of the Permian, carbon dioxide levels soared to 12 times those of today. Yet even more difficult to adapt to than the air were the terrifying animals of that time. The oceans were filled with giant sharks and massive bony fish swimming freely. On land lived small mammal-like creatures and massive herbivores known as anomodonts.
And even Gorgonopsis, distant relatives of ours, ran swiftly across the land.
Gorgonopsis looked like a strange mix between a dog and a dinosaur. Its danger was like mixing a dog with a Tyrannosaurus rex. Terrifyingly, it looked like a giant dog, but stood up to 3 meters tall.
It was still a ferocious beast without a cage.
In its mouth were long, razor-sharp teeth like bayonets. Just looking at it is enough to send shivers down your spine. Once you encounter this predator, escaping unscathed is almost impossible. But scientists believe they were among the ancestors of mammals. That means we and they are, in fact, distant relatives. Sadly, these creatures also went completely extinct at the end of the Permian period. According to paleontologists, this mass extinction wiped out 96% of marine species.
And on land, the devastation was beyond imagination.
This was the only time in Earth's history when even insects could hardly escape disaster. Around 80% of insect species went extinct at that time. Land vertebrates, including Gorgonopsis, also disappeared by about 70%. In terms of geological time, this disaster happened extremely quickly.
In only about 60,000 to 200,000 years.
Scientists speculate that the main cause of this mass extinction was the massive eruptions of the Siberian volcanoes,
releasing an enormous amount of lava.
These very lava flows formed the famous Siberian traps.
The eruptions released trillions of tons of sulfur dioxide and carbon dioxide into the atmosphere
and filled the oceans with toxic sulfur compounds. As a result, Earth's temperature spiked dramatically. The concentration of carbon dioxide in the air spiked from 400 ppm to 2,500 ppm. All of this happened at the boundary between the Permian of the Paleozoic and the Triassic of the Mesozoic.
It was also the moment just before the dinosaurs appeared.